Hey, I'm Patrick Paxson, and I'm a rising third year studying computer science and cognitive science here at UCSD. I'm also the team lead for Triton Robosub. Let's go meet the rest of the members.
My name is Richard Lai, and I am a recent graduate from UCSD studying mechanical engineering. I am the electrical team lead, and as the electrical team lead, I led the team in developing hydrophones.
Hi, I'm Ravi. I'm a rising sophomore studying electrical engineering, and I work on the electrical team.
My name is Javier Borja. I'm a rising fifth year studying electrical engineering, and I specialize in circuits and hardware.
Hello, I'm Donovan. I'm going to my third year studying mathematics and computer science, and in Triton Robosub I work on hydrophone firmware and algorithms.
Hey, I'm Alex Rivera. I'm a cog-sci machine learning major. I'm a rising senior, and I'm the software team lead.
Hello, my name is Imran Mateen, and I'm my fourth year computer science major, and I'm on the machine learning and computer vision team.
Hi, I'm Kunal Singla. I'm a rising sophomore studying computer science, and I work on controls.
Hi, my name is Ada Tafazoli Yazdi. I'm a senior at UC San Diego studying computer science, and I'm also a member of the software simulation suite team with Triton Robosub.
My name is Lucarno. I'm a senior studying computer science, and I work on optimization for the machine learning team.
Hey, I'm Will. I'm a rising second year studying chemical engineering, and I work on the Sim Suite.
Hey, my name is Roger, and I am a rising second year studying computer science. My role in the team is that I am a part of the simulation suite, and I work on linking the simulation with the actual sub.
Hi everyone, my name is Peter. I'm a rising senior. I study cognitive science with a focus of design and interaction, and I work on the team's website design.
Hello, my name is Dan Trong, and I'm a rising fourth year mechanical engineering major, and I'm also the mechanical team lead for Triton Robosub.
My name is Gabrielle Grack, and I'm a rising second year majoring in aerospace engineering. I work on the mechanical sub-team.
Hi, my name is Calvin, and I'm a rising second year. I major in computer science, and I work on the manipulator and hydrophones.
Hello, I'm Jack Griffin, and I'm a third year currently studying mechanical engineering. I'm a part of the mechanical team, and more specifically, working on the manipulator system, aka the grabber system.
Hello, my name is Jonathan Yee. I'm a second year mechanical engineering major, and I'm part of the mechanical team.
Hello, my name is Warren Chang. I'm a second year mechanical engineering major on the mechanical sub-team, and I'm in charge of designing the torpedo system.
Hi, I'm Alistair Visuet, and I'm a rising fourth year studying mechanical engineering and economics. I work on the mechanical team, designing the frame, electronics container, and battery containers.
Hi, my name is Ezekiel Nsali. I was a fourth year who recently graduated. I studied chemical engineering, and I worked on the mechanical team.
Hi, I'm Natalia. I'm a rising second year majoring in mechanical engineering, and I am on the mechanical sub-team.
Hi, I'm Samantha Hollander. I'm a 2020 graduate who majored in speculative design, and I am the marketing designer for Triton Robosub.
Now that you've met all the team members, let's introduce you to our robot. Here to talk about each of their respective subsystems are Richard, Alex, and Dan.
Hello, my name is Richard, and I am the electrical sub-team lead. This year, the electrical sub-team wanted to integrate a hydrophone system into our AUV to complete the hydrophone tasks. We began by researching which algorithm would work best and what hardware we would need to produce a successful hydrophone system. We referred to past teams' documents, professors, and mentors to help guide us in our process. We came to the conclusion of purchasing the H1C hydrophones given our budget and constraints. With the helpful and thoughtful guidance of our mentors and professors, we decided to pursue implementing the time difference of arrival algorithm and creating our own custom preamplifier board. Unfortunately, due to COVID-19, we were unable to perform extensive testing of our hydrophone system. For next year, we will continue to improve our hydrophone system and hope to implement a sonar system into our AUV. Now, I'll pass it on to Alex to go over the software side of our AUV.
This year, the software team focused on improving our data gathering and intelligence systems. The use of computer vision underwater presents unique challenges. Our team logged many hours researching and testing methods of improving performance of solutions such as deep learning models for object detection. Various methods of pre-processing were pioneered to accompany our robust models. A suitably large amount of data for training and testing purposes is often the bottleneck of solutions involving training a neural network for a task, especially with complex deep learning tasks such as object recognition. We proposed a unique way of alleviating that bottleneck substantially this year. while developing a simulation suite that would allow us to test the robot software without having to put an AUV in the water. We simultaneously began work on our simulation data collection tool. Using the Unity 3D game engine, we were able to create a virtual environment similar to the murky waters seen at the Robosub competition. Using this, we were able to collect a large amount of simulated data of the various competition objects automatically to bolster our smaller amount of real data. This was both a huge relief for those collecting and labeling data and helped us improve model performance and better understand the competition environment. Our controls architecture has begun to shift over to the Robotic Operating System, or ROS for short. Utilizing ROS, we're able to integrate more sensors more efficiently and design a system that is clear and concise. We are aiming to take the knowledge and experience we gained this year and take it to the next level for the upcoming year. Our control code will be completely rewritten from scratch so that we can better integrate custom sensors such as the Doppler velocity log. We are continuing to look into cutting-edge pre-processing techniques that will better allow our AUV to see underwater. Our simulation tool will continue to improve to better mirror competition conditions and will allow us to continue testing, even when we are working remotely. We can't wait to show off what we've worked on at Robosub 2021. Now over to Dan with the mechanical overview.
I'm Dan Trong, the mechanical team lead for Triton Robosub. The mechanical sub team experienced the most disruption due to this pandemic, and because of that, we were unable to refit our AUV. Prioritizing the health and safety of our team members and maintaining social distancing guidelines are very important to us. Because of that, we were unable to manufacture the design that we had in mind during spring quarter. However, the planned refit of the AUV will greatly enhance its capabilities. The addition of new sensors such as a Doppler velocity log and hydrophones will have enabled us to have more precise tracking of its movement and to determine its distance to certain targets. The addition of new components such as 2 additional thrusters, a custom-made torpedo system, and a custom-made grabber system will have allowed us to have more finer control over the AUV's movements and to attempt more tasks this year. However, due to the previously mentioned pandemic and to safety concerns, we decided to keep these modifications to a minimum. The DVL was still planned to be implemented onto the current AUV, however, due to this year's in-person competition being cancelled, that modification was never implemented. From there, the mechanical sub-team decided to move on and create a completely new AUV from scratch for next year's competition. Key features will include 8 thrusters for a full 6 degrees of freedom, important sensors such as a sonar system, a hydrophone array, and the Doppler velocity log. The mechanical sub-team is continually moving forward with its design through online communication channels such as Zoom, where we're able to discuss new ideas and new designs. We are also using Fusion 360 for our CAD work since it's easier to share files that way. Even though we are extremely disappointed to not be able to attend this year's competition, we're grateful for the health and safety of our team members. And we are very excited to produce a brand new AUV for next year's competition.
After a successful first year at the competition, we're really excited to implement some of the new things we learned from our fellow competitors. Armed with more knowledge and more members, we plan to tackle the gate, buoys, bins, and torpedoes using a machine learning aided computer vision model. We also wanted to use our new hydrophone array to find the octagon and integrate our DVL into a custom ROS architecture for our control system. Had we been able to complete our planned construction and testing phases, we were quite confident that our system would be successful at the competition. Preliminary results for our ML model yielded stellar results on the previous year's competition footage, and our hydrophone system was also measuring good results using a time difference of arrival algorithm. Our grabber system had also progressed the most before the pandemic, and so we were pretty confident in our ability to complete all of the missions. Unfortunately, the pandemic has limited our ability to actually integrate and test these new systems on a physical robot, but luckily we are already in the process of developing a Unity-based simulation tool to test our software. We recreated the entire competition in a virtual environment and added ROS integration with the tool to neatly fit it into the overall controls architecture, and it came just in time. Since we are already using Discord as our primary means of communication outside of the lab, a transition to a virtual setting was pretty smooth. However, this has been a difficult time for everyone, and it was not always easy to find the motivation to do robotics amidst a global pandemic and protests against systemic racial injustice. In addition, social and team bonding events were much more difficult to arrange as everyone was self-isolated. Our team managed to persevere through everything, and we're excited to tackle the challenge of Robosub again and see the Robosub community in 2021. Stay safe, and see you soon.